This is screencast 2.3 on island biogeography, and this is going to be a pretty short screencast. I only got a few slides, and I'll briefly go over the activity that goes along with this topic. Island biogeography is really exactly what it sounds like. You're going to be studying the ecology, ecological relationships of organisms on islands. And the reason we're studying these islands is because the geography of the islands has contributed to the specific development of the species, both flora and fauna, on those islands, different than you might find on a continent. So species exist on islands because they arrived from the mainland. Now, whether this is plants with seeds, like blowing in the wind, lizards can swim or raft, right? This lizard could be on a raft. It is not, though. It is just swimming. But they get there from the mainland. So you can look at species on the islands, look at similar species on the mainland, and try to draw connections between them based on the distance of the islands and the size of the islands. Most island species are specialists. So they've developed tastes and adaptations that are specific to the islands that are on. So that could be the flora, right? Could be the plants. But you see it very often in the fauna because animals evolve to consume only the food, the resources that are available on that island. Or maybe they hunt a certain type of prey, and that prey only exists on the island because it evolved to only eat certain plants on the island. The major challenge of this is that it makes them very vulnerable to invasive species. Now, of course, invasive species are a human construction, but this is a big problem on islands. A very famous one is on Guam, where the brown tree snake has hitched a ride on various vessels, and consequently it's eaten really anything that's on the ground that's smaller than it on Guam. And because of what happened at Guam, other island states or even nations, so for example, Hawaii, Hawaii is very careful about checking ships and planes that arrive at the islands and making sure that nothing has hitched ride on any of those ships or planes. All right, well, let's talk about the activity that you're going to be doing. So you're going to be looking at lizards from the Galatea genus on the Canary Islands off of Africa. There's 3 different species, and then one of those species has 4 separate populations that are different from each other. So this activity, you're going to look at some of the general principles of island colonization. You're going to construct some different family trees. And how this works is that the oldest species, the one that's least changed over time, can go at the bottom, right? If you're looking at this example, you can see at E, that would be the oldest species. And then the species are newer and more specialized. They branch off from the original one. So you list all the species on the right, and then you create the branches to match them up. You'll be creating several different family trees, one based on the island geography, one based on the lizard morphology, and one based on genetic analysis, and then trying to determine which of those family trees is the most accurate. When you're doing the genetic analysis, you're going to use this table 2, which shows genetic differences between different populations. A higher number means more differences. So you can read it left to right, where if you're looking at row 7, Galatea galati from the Hero Island has 49 DNA differences from Galatea stellini. And so that means these 2 species are very different. Whereas if you come over here to Galatea galati gomera, that's very similar to the Hero population. Figures and maps you're going to get map 1 that shows the islands and their distances. You're going to get figure 2, which shows the morphology of the lizards and their relative sizes. Um, map 2 shows the distribution, which populations are on which islands. And then table 1 shows the age of the Canary Islands. These are volcanic islands, so they've been dated either with radioactive dating or based on their distance, the plate movement from the hotspot. Let me know if you have any questions on island biogeography as you go through that activity.